Students, now let us take the first scenario, that is we have different origin and destination, and we will look at this with the help of an example. Now assume that there is an ABC trucking company that is in the business of transporting furniture from the factories in city A to the wholesale stores in city B. So we have our origin, which is A, and a destination, which is B. The transportation network consists of the intermediate cities, and which are as follows. So we have intermediate cities C, D, E, and F, and the distances are given. Just remember, for a graph or a network, that if there is no direction, that means it's bidirectional. What does it mean? I can go to from city A to city C, and I can come back from city A to city C to city A as well. So it's a bidirectional graph if there is no direction given on it. The values along the link show the distances between adjacent cities, determine the shortest path from A to B. So what we need to do, we need to determine the shortest path. So the procedure, 4-step procedure, which we have seen before, we will apply on this network. So iteration would be to have a solved node. Solved node means the origin, first of all, from where we will be starting. So we have A with us. A is directly connected with C and D. You can see it from the network that A is directly connected with C and D. So these are the directly connected nodes, and we have to look at the distance. Now A to C distance is 30, whereas A to D distance is 40. So we need to select the shortest distance and the connected node. So we will connect A with C because the distance 30 is smaller than 40. So the first thing would be to select AC with the distance 30. Now we have two nodes, two solved nodes with us. The one is A, one is C. Now which nodes are directly from A to C? We know that there is a node which is from A to D with a distance 40. Now C is also a part of our solved node, and there are two nodes, which is B and E, which are directly connected with C. But for coming to C, we have to first of all go from A to C. So the distance is 30. Then the distance from C to B is 40. So the total distance would be 70. And the distance from C to E is 20. So 30 plus 20 will give you 50. Now you should know how to do these calculations. The first 30 is actually from A to C. So the least distance is from A to D, which is 40, 50 and 70 are actually higher than that. So we select the shortest distance, and we have one more solved node, which is D now. So the third iteration would be, now there is no node which is connected with A which is not selected or solved. So A would not be a part of your third iteration. In fact, C and D would be a part of your third iteration. So C is connected with E, C is connected with B, D is connected with E, D is connected with F. If you see the network, you can easily take their values as well. Now solving it on the same pattern, first of all, if we are at C, that means it's from A to C, which is 30, plus the distance from C to E, which is 20. So we get 50. On the similar pattern, from C to B, it would be 30 plus 40, 70. From D to E, it would be 40 plus 20, 60. And D to F would be 70. So which one is lower? 50 is lower. So we will connect C with E. Now we have C, D and E as solved nodes. And there is only one connection available, that is C to B. There are still two connections available for D, and there is one connection of E to B. On the similar pattern, we solve it, and the least distance would be from D to E in this iteration, that is 60 from E to B. Now B is our destination on the network. That is the city which we want to reach. So what will happen? We can see that the shortest path would be from A to B is through C and E. Are you getting it? So first of all, my shortest path would come from A to C, then C to E, and then from E I will go to B. So A, C, E, B would be the path. D would not be required because D was never solved afterwards. So the distance would be, we will be going first of all from A to C, then from C to E, and then from C to B. Students, now you have seen the shortest route problem or the shortest path problem, which is primarily based on the distance between different cities. Of course, your origin and destination should be different for implementation of this procedure. Thank you.